Sensor fusion is a term that gets used in many different contexts, and it is very much a polyseme, meaning a phrase that has different meanings depending on who you ask, but these meanings are usually related, and we're going to go over a couple of those. So in a basic example for detection or classification or whatnot, we start with some sensor data, we usually have some algorithm, and then we get a detection. With sensor fusion, one way to do things is to actually merge different sensor streams into one module, into one stream, and then feed that into our algorithm to get an improved detection as opposed to just using one sensor. This is the example, the classic way of doing stereophotogrammetry, for example, where we have 2 or more cameras looking at the same event, and because we have those cameras at different positions in space and they are synchronized, we can then create a disparity map and get depth information for each pixel. That is one way in which we can do sensor fusion. Another way would be at a slightly higher level. So let's assume that we have different sensors all observing the same event, but instead of merging their raw data immediately, what we can do is we can have different algorithms or neural networks looking at the sensor stream from each sensor and extracting information. And then what we can do is fuse that information together to get an improved detection. So let's take an example. Assume that you have a camera and a LiDAR, both observing the world around the vehicle. And let's assume that we are trying to detect a stop sign. In the LiDAR space, we can imagine an algorithm which is evaluating the intensity of the return point. So the sign is retroreflective, it has a retroreflective paint, and it will appear shiny next to all the other objects in the LiDAR. In addition, since the LiDAR has a lot of dense points in many cases, and the accuracy, the per point accuracy of the LiDAR is pretty good, we can then evaluate the geometry of the sign and figure out whether it is actually a stop sign or not. So that gives us information about that sign with a particular confidence, let's say 85, 90%, etc. So with another sensor, with the camera, we can be looking at that same stop sign. And we know in the RGB space that the sign should be some sort of shade of red. And we can imagine also how we can have a neural network that's using some sort of convolutional layers to extract and classify the sign as a stop sign. So we also extract some information from a camera frame, and that has a particular confidence as well. We put the two together. And the idea is that even though our confidence was slightly lower, let's say, than desired in those two cases, the LiDAR and the camera, we can still get an improved confidence of our detection after the fusion layer. And that is also an example of sensor fusion.